All right, I'm here to help you understand domain and range. I get this question all the time at school. 22 years of teaching, and it just never stops. I don't understand domain and range. Could you help me out? So I put together a presentation where I'm going to walk you through how I work with students one-on-one to help them understand domain and range. So I'm confident it's going to help clear things up for you, and hopefully you'll be more successful all the way through algebra, because this is something you're going to use through calculus and beyond. So you might as well learn it now and get it out of the way. So I'm going to try to demystify domain and range for you. Now on this screen, I'm just showing you what an example answer would be. So here's a graph. The domain involves x values, and sometimes we write it as an inequality, and sometimes we write it in interval notation. Usually in upper level math classes we use this interval notation, and I just did a video on interval notation, so I'll be sure to link that at the end of this video to help you out. And then range is always about the y values, and we sometimes write it this way as an inequality, or once again as interval notation. All right, so let's start stepping through this if we could. So here I've given you three different functions: function f of x, g of x, and k of x, and some of them are actually kind of crazy. So let me first explain that domain is x's. Domain is x's and x's only. Let me grab the pen here. It's x's, the x values. In fact, it's what's allowed to go into a function. What is x allowed to be? What can go in here? Are we allowed to put x equals 1? Yeah, if we put x equals 1, what do we get out? 1 squared is 1. If we plug 0 in, what do we get? 0. Are we allowed to plug negatives in? Sure. Negative 2 times itself, negative 2 squared, would be positive 4. You see these numbers on the left side here, these are the domain. They are the numbers that we're allowed to plug into a function. And I'll get to that whole allowed to be here in a second. So what is allowed to go into this function? Well, you can see anything can go into this. So the domain here would be all real numbers, and we can use this fancy symbol here with the capital R to mean all real numbers. Or interval notation is like this, from negative infinity all the way to infinity. Remember, you always put the smaller number first. So that problem's all real numbers with the domain. So I chose that because that's kind of common to be able to plug anything you want into it. Now let's look at g of x now, because this is a little different. What do you know about square roots and what has to be true under the radical? Do you remember? Underneath the radical always has to be bigger than or equal to 0. Like you can take the square root of 0, that's 0. Square root of 1 is 1. Square root of 4 is 2, and so on. But the square root of negative 4, those are those imaginary numbers, and I'm not going to deal with that here in this video. We're just dealing with the real number system. So the domain here, if you were doing a t-chart, the lowest number you would ever see would be 0. We would get the square root of 2 out, which is a decimal. I'll skip to 4. Square root of 4 is 2. I guess I should be writing g of x. There we go. I saved it, right? So you can see a 0 turned into a 0 and such. So once again, here's the domain. The domain is all real numbers, but they've got to be 0 or higher. So how do we write that? The domain here would be x is greater than or equal to 0. That's one way to write it. Or in interval notation, we write it 0 to infinity. And remember, I use that bracket because 0 is included in this. So typically, I think your teacher's going to want you to be writing the interval notation, and I'm not going to keep writing them both as we go through this, but I just wanted to write them both for now. Now look at k of x. This is kind of a crazy rational function. It has a numerator and it has a denominator, and that's okay. Some functions have numerators and denominators, but there's something we have to watch in rational functions. And I have a whole bunch of videos on rational functions because they are tricky. Do you remember what has to be true? The denominator cannot be 0. This can never be 0 because you're not allowed to divide by 0. You're not allowed to divide by 0. So we got to be careful here. And we need to make sure that x minus 5 is never 0. So what I'm doing right now, this is kind of silly, I like to say we're trying to find the problem children. We're trying to identify the numbers we have to stay away from, that we cannot shove into this machine because the machine will just blow up if we try. So if I add 5 to this side, x is, and this side, I get x is not allowed to be 5. So you could say all real numbers except for 5. That's the domain. Or I could write it like this. I could say, starting at negative infinity, I can go all the way up to 5. However, I've got to put a parenthesis there, and I've got to skip it. So I'm going to union it together with another interval. 5 to infinity. There we go. So there's your answer for the domain on this one. All right, I bet you're screaming at your computer or phone right now because you're wondering, well, Mr. White, what about the x plus 1? You are allowed to have a 0 in the numerator. So negative 1 is allowed to be plugged in here. We just get 0 divided by negative 6 if you plug negative 1 in both places. That's okay. The top is allowed to be 0. So when you're working with the domain, don't even bother looking at the numerator for the most part. You really only have to find the problem children. And right here, it only is the value that causes a divide by 0 error here. All right, so hopefully that's making sense. On this page here, I wanted to stick to explaining it with numbers and a little bit of algebra and things. Okay, we're going to get to graphical understanding here very soon. In fact, right now. So we're going to look at the same 3 functions, and I have the graph already set up for you to look at. So let's look at x squared. Domain, do you remember I said it's the x values? So here's another way to explain it. This is where it really, I think, helps students. Is when I say a domain is how far left and how far right the function exists. How far left and how far right does that function exist? Now, this parabola that we're looking at has arrows on the left and right. So how far left does it travel? On the x-axis, on only the x-axis, you see how it just keeps going? Like if I were to shade this in, this graph exists everywhere left and right. So do you remember what the answer was? The domain was all real numbers on this one. And that's because it exists everywhere left to right. What about the square root of x? You see it graph there. How far left does it go? It starts right here, and then it goes up like this. It's not a parabola. It's only half of a parabola, and it's on its side. But it abruptly starts right here. So the domain is this right here, because remember, it's x values. Let me shade it in for you. Here's the domain on this thing. It's quadrants. Actually just quadrant 1 really, because it never goes under the x-axis, but it's everything from the y-axis to the right. Okay, so how do we say that? We say x starts at 0 and goes to infinity, but I made a little mistake there, right? I got to change this to a bracket because there really is a closed circle here. It does get there. It does start at the origin. So you can visualize the domain, how far left and how far right this thing goes. And that's a visual way to come up with the domain. All right, what about this crazy function here? This was a rational function. Rational functions sometimes have these things called asymptotes. They are values that get skipped, that the function never goes through. So if you were to try to find k of 5, the answer would be it does not exist. Your calculator would say error. Okay, in that part of the table, your TI-89 would say error on there. So it doesn't exist there. So you see how we can visualize this one. It's how far left does it go? Well, it starts at negative infinity, and then it goes all the way up to here, right? And then it skips 5 and then keeps going the other way to infinity. And you remember what we wrote? We wrote negative infinity all the way to 5, union 5 to infinity. You see how that works? So we can visualize the domain as well. That's a good way to do it. So I wanted to show you the algebra as well as the graphical understanding. Okay, so here's a graph. Pause the video. What's the domain? What's the domain here? How far left does it go? I'm going to do a couple of crazy things for you. So that 3 and the 1, the negative 1, those are y values. When it comes to the domain, you need to ignore those, folks. Where does this graph exist? It exists from, whoops, I guess I can use that. It exists from here to here. That is -4 all the way to 1 with a bracket. You see how the graph goes from here to here, but it's got an open circle. So it ends up being kind of like that. It's how far left, how far right does the graph go? That's the domain. Easy peasy. How about this one? Again, pause the video. How far left, how far right? Are there any values that get skipped? Right, how far left does this go? 1, 2, 3, 4, 5. -5. And it looks like it starts there with a closed circle, doesn't it? And then it's traveling this way. And what about right here? That's called a jump. But let me ask you this. Does f of -2 exist, or is it a does not exist or error situation? Here's -2. It exists. It's right here. It's at -2. So f of -2 is -2. So it exists. So that works out okay. So we'll go all the way through -2. We don't have to skip that. But look at that. The next one, f of 1. F of 1 is an open circle there and there. So at 1, that's where it does not exist. So we have a does not exist situation. So we're going to go all the way to 1, and we're going to skip that number. And then, do we go to infinity? No, not quite, right? Because right here, at 1, 2, 3, 4, 5 is where it stops then. And it's a closed circle. So I'm going to go ahead and put a bracket there. So from -5 to 1, and then from 1 to 5. There, I had to sneak that negative sign there. Does that make sense? Domain is how far left and how far right the graph exists. Okay, so I said I was going to cover domain and range. Range is very similar, but it's up and down. So domain was all about left and right x values. So range, listen to me carefully, is a lot easier to figure out if you have the graph. If you have the graph, it's so simple to see the range, just like it was simple to see the domain. So take a look here. How low does this go? Because now we're looking at y values. How low does it go? Well, it has what we call a minimum right there. It bottoms out at y. Let me label this graph here. This is y equals 0 right here. And then when does it stop going up? Never. So we would say the range is y is greater than or equal to 0, or in interval notation, we would say from 0 to infinity. Okay, and by the way, we always put a parenthesis on infinity because we can never actually put a closed circle there. We can never actually touch it. So that's how I explain it at least. We always put a parenthesis on infinity. All right, what about that square root function g of x that you see there in blue? How low does it go? It goes as low as y equals 0 again, and then it keeps going up. It gets very slow to go up, but it is continuing to go up. So the range here is once again going to be y is greater than or 0, or let's write it like this, 0 to infinity. And that's the range for that. So looking at the graph makes that really easy. All right, let's look at our crazy function, our rational function. Remember, you're only looking at y values, folks, only y values. So I do see that there is another asymptote here. You see how there's this value that gets skipped. And that looks like y is never 1. Y is never 1. And you see that we've got arrows going all different directions here, up and down. So how low does it go? Negative infinity. How high does it go? Infinity. But there's stuff that we have to skip in the middle, isn't there? We have to skip 1. So I'm going to skip 1 just like that. So negative infinity to 1 with a parenthesis, union 1 to infinity. And that's the range of that function. All right, so graphical method is the way to go when it comes to range, I'm telling you. It's really hard to figure out when you're just looking at the function. I mean, you can think about it and figure it out, but having the graph makes it so much easier. So in fact, here I didn't really give you the graph at all, did I? So let's think about this for a second. So what kinds of outputs will this thing do? It's always positive. Every single number that we plug in will always be positive. So that's why y is always bigger than or equal to 0. Same thing with the square root. Think about the square root function. It will never spit out a negative unless you're dealing with imaginary numbers. So once again, y is greater than or equal to 0. Now these here, I would strongly recommend that you go to that graph because it is really challenging to figure out. You actually have to use a limit from calculus and see, if there's any horizontal asymptotes. Horizontal asymptotes are where if you imagine sort of getting rid of this extra stuff here, do you see how those cancel? X divided by x is 1, and there's a 1-to-1 ratio there. So that means k of x is approximately equal to 1 at x equals plus or minus infinity. So when you're plugging really big numbers in, it's going to look a heck of a lot like the number 1. So that's kind of how we know it's coming in for a landing on 1, and that's a horizontal. That's more of a pre-calculus concept, or at the end of Algebra 2. So for this one, if you're in Algebra 1 and you're talking about domain and range, just go to the graph. Just go to Desmos, look at it, and see how high and how low it goes. Okay, so what about the range on this one? We looked at the domain on this guy earlier. How low does it go? It goes as low as -1, and then it goes as high as 3. Goes as low as -1 and as high as -3. So we would say y is between, this is how you do the between stuff. You haven't seen me do one of these yet. From -1 all the way up to or equal to 3. But in interval notation, we do parenthesis -1, comma, 3 with a bracket. Okay, so that's the range on that. What about the range on this one? How low does it go? Remember, range is just how low, how high. It goes as low as -4, but it never actually gets there, so I'm going to use a parenthesis. And then it goes up, 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 but ooh, look here. It gets to 2. As you're traveling up in this elevator, it gets to 2, but then it skips, and it starts again at y equals 1. You see that? And I have to put a parenthesis there because there's an open circle there. And then it keeps going up, and it keeps going higher and higher. You see how it does actually exist there. Keeps going higher and higher all the way up to this value right here, which is at its peak, which is 5, and that would be a bracket because this is a closed circle right there. So range is all about starting from the bottom and describing where it exists from, oops, I'm sorry, this should be -1 and this should be -2, just like that. That probably makes more sense for you, right? So this is -1 and -2. All right, next slide here. So let's think about this one. Your teacher gives you the function f of x equals x to the third plus 2. What's the domain? Well, you could go to your TI-85 or 83 or 88 or 80 gazillion, whatever it is now, and look at the graph, but it's not really necessary. What are you allowed to plug in here? Are you allowed to plug positives? Sure. Are you allowed to plug negatives? Yeah. Are you allowed to plug zeros and decimals and everything? Yeah. So this thing has an all real numbers as far as the domain. What about the range? I don't know if you've learned, but x to the third graphs look like this. They look like this. And notice, how low do they go? -infinity. How high do they go? Y equals infinity. So once again, it's all real numbers for the range on that. So an x to the third function will always be domain all real numbers, range all real numbers, unless they put some endpoints in there, which I did not. Whoa, what about this mess? Oh my goodness. We're going to do this without a graph. And then I believe on this last slide, I have the graph. So let's try to do it without. Do you remember what I said about the denominator? This can never be 0. So let's start there. We got to find our problem children. Our problem children are numbers that we have to stay away from and keep away from this function. So I'm going to divide by 2. X equals 2.5. I'll go ahead and write it as a decimal. 2.5. So x is not allowed to be 2.5 as far as inputs go. But there's something else, folks. You see something else? This square root of x. We are only allowed to plug positives in there. So, and at the same time, we're only allowed to pick positives. So I'm going to write that like that. How do we merge that together? Well, basically, we're allowed to plug 0 into this function. We're allowed to plug everything else but 2.5. We got to skip 2.5. So I'm going to write it like this, 2.5, and then we could go all the way to infinity on the other end. So see how I did that sort of algebraically and numerically and analyzing that to figure it out. Now what about the range? The range is really hard to do without the graph. So look what I've got for us. I've already got the graph set up, and let's see, and I plugged in the answer there from the previous slide. All right, so the range, how low does it go? You see how it goes way down here. So it starts at negative infinity, it goes all the way up to negative 1. See if I can get my negative signs right this time. All the way up to negative 1. And it looks like it gets there, right? There's a closed circle there. But then it skips. And it sure looks like this is coming in for a landing on the x-axis. So in other words, y is never going to be 0. We're going to always be a hair above 0, a little bit above 0. And then we're going to go forever northward, upward there. So that's the range on that thing, okay? All right, my last slide is just a reminder. I just recopied that first slide. Remember how crazy this looked and you wondered, how would I ever know how to do this? Well, hopefully you do now. You can see this graph here. The domain is 2 and under. X is always under 2. And then what about the range? The range is everything under 3. Everything under 3. So y is less than 3. And that's how you say that. See how easy that was? All right, well, I hope that this was helpful for you, and I hope that, now when you learn about or your teacher brings up domain and range, you won't freak out and forget about this, because it's actually really easy, right? Domain is x's, range is y's. All right, until next time.